All right, hello everyone. This is a recording of the lesson for section 3.1 from Math 1050, Quadratic Functions. It'd be best while watching this video um, to pause so that you can write down everything that you need to write down so you don't miss something, or to pause it and have time to practice on your own before you see the answer, just so that you're getting some practice there. But these are learning targets. We need to be able to write a quadratic function in standard form. That's also known as vertex form. That's going to be a key topic in this section is the vertex of a quadratic function, which leads to the next learning target, find the maximum or minimum values. Really, that just means finding the vertex of a parabola. And then finally, write the equation of a quadratic function when given the vertex. So just real brief recap for you. Quadratic function has a graph, and the name of the graph, parabola, something I'm sure you're familiar with. The key feature we're going to focus on today on that parabola is the vertex. And with the parabola drawn here, the vertex is at the bottom of the function, so that would be known as the minimum value. This function has a minimum value. If this parabola were flipped upside down, the vertex would be at the top of the function, and then it would be known as a maximum value. So either the function has a minimum value or it has a maximum value, and that's what we're going to be finding in that learning target. So that's the graph of a quadratic function. It's a parabola. The equation of quadratic functions, we're going to be looking at two different forms in this lesson. One of them is the form that's maybe more common, the general form ax squared plus bx plus c. But the form we're going to focus a little bit more on today in this lesson is what's known as the standard form, also known as vertex form. The reason it's called vertex form, or referred to as vertex form, in addition to standard form, is the location of the vertex is embedded within the equation. So the opposite of h and then k, those two values, form the location, the coordinate location of the vertex h comma k. So this first learning target is really just finding the vertex when the equation is written in standard form. So when it's first given in standard form, like this first example, stating the vertex and sketching the graph is pretty easy. So this first equation here, f of x is 2 times x plus 2 squared minus 3. This is in standard form, or vertex form. So first thing we would want to do is simply state the vertex before we graph it. Remember, the vertex is the opposite of this value, and the reason it's opposite, if you remember from the last chapter, section 2.6, transformations of functions, this transformation would cause the graph to move 2 units to the left, and then this transformation here makes the graph move 3 units down, so the location of the vertex is -2, comma -3. Now, once we know the location of vertex, we can start to graph. So -2, comma -3, there's the vertex. And then if we wanted to keep track of the points we have -2, comma -3. That's one of the points on our graph. I'm going to figure out where the graph is when x equals -1. So if I plug a -1 in for x, -1 plus 2 is 1. 1 squared is 1. 1 times 2 is 2. And 2 minus 3 is -1. So when x equals -1, y is -1. So there's a point on the graph there. And because of symmetry, that point gets reflected over to here. So when the quadratic function's equation is given in standard form, stating the vertex pretty easy, and then it makes it easy to sketch the graph. Now, if the equation is in general form, like this one, f of x equals x squared plus 4x plus 1. Then stating the vertex can be done by one of two ways. I'll show you the first way here, by writing the equation into standard form, or transforming the equation into standard form. Right now this equation is in general form. If we can transform that equation into standard form, we're going to be able to easily see where the vertex is by looking at the equation. So the technique is called completing the square. This technique I'm sure you have heard. You may not remember it, so the basis of this technique is being familiar with what's called perfect square trinomials. The word trinomial, tri means 3, so this is a trinomial because it has 3 terms. But the reason it's called a perfect square trinomial is because of the way it factors. It factors into the product of 2 identical factors, x plus 1 times x plus 1, which can be factored to x plus 1 squared. And that's the key. The key is that it factors like that. So if you look at all of these that I've written here, these are all perfect square trinomials because of the result of factoring. And then the question then is, how do you create, or how do you form a perfect square trinomial? So this problem here, x squared plus 12x plus blank, that phrase complete the square really means what value do I add here to complete this into a perfect square trinomial. And looking at these 5 that I've written, you might recognize a pattern. For example, this one is 3 times 3, this term is 3 plus 3, or this term is 4 times 4, so the middle term is 4 plus 4, or here this term is 5 times 5, the middle term is 5 plus 5. That's the pattern that arises with these perfect square trinomials. So if you're left with having to create one or form one, you look at this middle term as, alright, this 12 is 6 plus 6, so then the term that would complete the square would be 6 times 6, or 36. X squared plus 12x plus 36 is a perfect square trinomial because it factors into x plus 6 times x plus 6, or x plus 6 squared. So this one here, x squared plus 14x plus something, we need to complete the square now to form a perfect square trinomial. So if we recognize this 14 as 7 plus 7, then 7 multiplied by 7 is 49. And then that allows this to factor into x plus 7 times x plus 7, or x plus 7 squared. So that's the technique that's used in this idea of writing a quadratic equation in standard form when given general form. It's called completing the square. See, the problem is this 1 right here. That 1 isn't the value we need there to form a perfect square trinomial, because this is not a perfect square trinomial. So what I'm going to do is move that 1 to the other side, really creating room where that plus 1 used to be. Now there's a space there where I can add a value that's going to complete the square to form a perfect square trinomial. So if I recognize that 4 as 2 plus 2, then the value that would complete the square is 2 times 2, or positive 4. And one of the things that students struggle with remembering is that this is an equation, so whatever you do to one side, you have to do to the other. I've just added 4 here, so I have to add 4 here to keep the equation balanced. So I'm going to add 4, making f of x plus 3. And now the right side, the reason for adding that 4 there was so that it can be factored into x plus 2 times x plus 2, which can then be written as x plus 2 squared. And if I move the 3 back over, I have the equation. It's the same function that I started with, but rather than looking at the general form here, we're looking at the standard form here. These are both equivalent to each other, just in different forms. And looking at it in standard form, we can identify the vertex as -2, -3. So for part B, I'm going to hit pause and try to do the same technique. Write the equation in standard form by completing the square, after which you can locate the vertex. So this is not a perfect square trinomial because of this. That 7 isn't the right value to form that trinomial, that perfect square trinomial. So go ahead and move that 7 over. So you got to figure out what value would I add here to complete the square to form a perfect square trinomial. So the 10 there is just 5 plus 5, or if you wanted to argue, it's -5 plus -5. And then -5 times -5, or 5 times 5, they're both the same, would give you the same value. It's 25. 25 is the value that completes the square there. The typical formula that most college textbooks use is this value here is half of b squared, where this value right here is b. So now if we add 25 to this side, we've got to remember to balance the equation by adding 25 to that side. So now we have f of x plus 18 equals, and now that you have written it as a perfect square trinomial, you're going to want to write it in its factored form. So x squared minus 10x plus 25 is x minus 5 squared. Working hard. And then move that 18 back over to the other side by subtracting 18. And we have the equation of the function now in standard form. And then easy enough to locate the vertex now would be 5, -18. Some of the problems you have to pay a little more attention to, particularly when there's a leading coefficient of that squared term. It's not a different process, it's just one extra step that you need to pay attention to. So with this one, you're still going to move this value. I'm going to move that value to the other side of the equation. So add 10 to both sides. And now here's where it becomes a little different. This 3 as a leading coefficient needs to be factored out. And it's not factored out of that 10 anymore because the 10 is gone, because I moved it over here to the left side. I'm factoring out the 3 from the 3x squared, leaving x squared, plus 6x. And notice I'm going to close the parenthesis so that it includes the new value we're going to add that completes the square. So I'm closing the parenthesis way out there. So we're completing the square now on this perfect square trinomial with the 3 factored out of it. So half of b, where this is b, half of b is 3. 3 squared is 9. So we're adding a 9 to complete the square to form a perfect square trinomial. And listen carefully to this, because this is a very, very common mistake. What we need to do now is balance out the equation. I've added something to the right side that I have not yet added to the left side. The question is, what is it I have added? And some students think, well, you've added a 9. I've added a 9 inside the parenthesis, yes, but I haven't really added a 9. I've added this value here, 3 times 9, which is 27. If I were to multiply this 3 back into that parenthesis, that 9 would turn into a 27. So I've actually added 27 to the right side, so I've got to add 27 to the left side to keep it balanced. So now I have f of x plus 37 equals 3, and then x squared plus 6x plus 9 is x plus 3 times x plus 3, or x plus 3 squared. And then move that 37 back over to the right side by subtracting. And then we have the location now of the vertex. By looking at it in standard form, the vertex is -3 comma -37. Now the reason that it's being stressed so much that we're finding the vertex is in application problems, in physics and motion and in economics and various other fields. It's very useful to be able to find a minimum or a maximum value of a quadratic function. And you'll see that phrase pop up a lot, find the minimum this or find the maximum that. And if we're talking about a quadratic function, really all it's talking is, or what it means is, find the vertex. If you see it saying find the minimum value or find the maximum value, what it's really saying is find the vertex. And so we spent a lot of time writing the equation into standard form so that you can easily find the vertex by looking at the equation. Like looking at this equation in standard form, you can easily tell where the vertex is, thus being able to state the minimum or maximum value. If you know that the parabola faces up because the leading coefficient here is positive, then you could state that the vertex is a minimum value, because if the parabola is facing up, then the vertex comes at the bottom like that, so you'd say it's a minimum value. If the leading coefficient is negative, causing the parabola to flip upside down, you would say the vertex is the maximum value. So if the function is in general form, you can find the vertex by completing the square. That's what we just did to write the equation in standard form. Or there's a simple formula called the Vertex Formula, which I'm going to show you here. So this example, if the function is already written in vertex or standard form, then it's simply a matter of just locating the vertex from the equation. So the vertex is the point 4, 3. Now we've got to decide, is that a minimum value or is that a maximum value? And the question can be answered by looking at that leading coefficient. It's -2. What that means is the graph of this quadratic function, if we go 4 units to the right, 3 units up, the -2 is a reflection. It's a vertical reflection that causes the parabola upside down. Vertex appears at the top of the parabola, making it a maximum value. So last thing would be to state that this is a maximum value, not a minimum, because this vertex is at the top of the parabola. If the function is given in general form like this, then you can do what we just practiced in that last learning target. We can complete the square to write this in standard form. I'm going to show you that way. I'm going to split this into 2 sides so you can compare methods. Here on the left, we can complete the square. So I'm going to add 1. I'm going to move this -1 to the other side by adding 1, then factor out the 2. Then I got to figure out what completes the square, and then half of 4 is 2, 2 squared is 4, so I would add 4, but I really didn't add 4, I added 2 times 4, which is 8, so add 8 to both sides, and now I got f of x plus 9 equals 2 times x plus 2 squared. That x plus 2 squared came because x squared plus 4x plus 4 factors into x plus 2 times x plus 2, or x plus 2 squared. And if you subtract the 9 back over to the right side, you get x plus 2 squared minus 9. So the vertex is the point -2, -9. So that's one way you can find the vertex, is by completing the square to write the equation in, in standard form. The other way you can do this sorry, just trying to orient this, is, now let me skip down here. Oops. There is a very simple formula called the Vertex Formula. And it's x equals the opposite of b divided by 2a. And this is assuming you're looking at the equation in standard form, or sorry, in general form, ax squared plus bx plus c. So you need the values of b and you need the values of a. And this will tell you the x part of the vertex. And remember, a vertex is x and y. So this vertex formula tells you the x value of the vertex. And once you have that x value, you can plug it back into the equation to find the y value. So going back to the function that we just had, if we use the vertex formula, the opposite of b would be -8, because this is b right here, so the opposite is -8 over 2 times a, and this is a right there, so 2 times 2. So what this is telling me is the vertex has an x value of -2. It doesn't tell me the y value. I can find that, though, by plugging in the -2 back into the function. So I need to find f of -2. So this gives me 4 times 2, which is 8. 8 minus 16 minus 1. This is -8 minus 1, which is -9. So we have the vertex of -2 comma -9. Same thing over here, vertex -2 comma -9. So both ways have their advantages. Knowing how to complete the square to write something in standard form is actually a necessary skill to have if you're moving on to calculus and various other fields, physics, for example. If you're just trying to find the vertex for the sake of finding the vertex, and that's all you need, oftentimes it may be a little quicker just to use this vertex formula. And particularly when you have the general form of a quadratic function, and this middle term here is an odd number. It can be a problem because the way that we find the value that completes the square is by taking, if you remember that quick little formula, it's half of b squared. Well, it's hard to cut an odd number in half without using fractions. So in this function here, x squared plus 5x plus 7, completing the square can get a little tricky. So for this one, part C, I'm going to find the vertex just by using this vertex formula. Okay? And I got so caught up in finishing the problem that I didn't actually answer the question here on part B, so let me scoot back up here. Now the question was not just to find the vertex, but to state whether it's a minimum or a maximum. And because of this leading coefficient is +2, the vertex was -2, -9. And I'm going to call this a minimum value, because if we were to graph this parabola, this value of +2 causes the parabola to face upward, making the vertex at the bottom of the parabola. It's a minimum value. Okay, going back here to part C. I'm going to go right into the vertex formula. The opposite of b divided by 2 times a. A in this case is 1. So I know the vertex has an x value of -5/2. What I need to find, though, is the y value. I can find that by evaluating the function at that value. So -5/2 squared is 25, +25/4. 5 times -5/2 is -25/2. Now you can, at this point, most definitely get out a calculator. There's no reason to have to work with fractions by hand. But if we wanted to get all these to have a common denominator, it'd be 25/4 minus 50/4 plus 28/4. This is just getting all those fractions to have the common denominator. And then if we added that all up, let's see, we'd have 25 minus 50, that's -25, plus 28. So that's 3/4. So the vertex is -5/2, 3/4. Or if you wanted to use decimals instead of fractions, that's fine. It would be -2.5, 0.75. So we have the vertex there, and because the leading coefficient is positive, we know the vertex opens up. So this would be a minimum value for the vertex. Okay. This learning target here, so when given the vertex of a quadratic function, we can write the equation in standard form. But we do need a little bit of information, additional information. So this example here, we have a vertex at the point 2, 3. We also know that the function or the parabola goes through the point 3, 6. That's important information which we'll need here in a second, but just looking at what we've been given, if we're looking at the graph, here's the vertex here at 2, 3, and the parabola goes through this point of 3, 6, and because parabolas are symmetric and the vertex in this case would be at the bottom, we would rightfully assume that the other side of the parabola would look like that. So we know that this parabola faces up, which means the leading coefficient is positive. And the fact that the vertex is at the point 2, 3, so let me just write the equation here in standard form. Knowing that the vertex is at the point 2, 3 allows us to partially fill out that function as f of x equals a times x minus 2 squared plus 3. What we don't know and have not been given is this value of a. We know that a is positive because the function opens up, or the parabola opens up, but we don't know the exact value of it. And that's where this additional point is necessary, because this additional point gives us another x and y value, which I can plug in to the function, because f of x really is just y. So if I plug in these values, or this point, in for this x and for this y, that's going to allow me to solve for that remaining unknown value of a. So if the point 3, 6, the 3 would go there, and the 6 would go there. So I can write that equation as 6 equals a, and then instead of x minus 2, I can replace that x with a 3. And then I can solve that equation for a. So 3 minus 2 is 1, 1 squared is 1, 1 times a is a, so 6 equals a plus 3. Subtract 3 on both sides, and I get a equals 3, which now allows me to write the complete equation, f of x equals 3 times x minus 2 squared plus 3. Now finally, the latter part of your homework is going to have some application problems. One kind of like this one. So go ahead and hit pause, write this one down. Now the question here comes at the end. Find the maximum height of the ball and how long it took to achieve it. I can't stress how important this word right here is. Find the maximum. This whole entire lesson pretty much has been dealing with the vertex of a parabola. Now, the equation that's been given is the equation of a quadratic function, and all quadratic functions, the graph is a parabola, so it has a vertex. If you see this phrase, find the maximum or find the minimum, and you're dealing with quadratic functions, really all it is telling you to do is find the vertex. So when it says find the maximum height of the ball, it's saying find the vertex of this parabola, because this parabola models the height of the ball. So finding the vertex, I'm going to use the vertex formula, and remember the vertex formula is the opposite of b divided by 2a, and I've got this function here where this is b and this value here is a. So the opposite of b, so x, sorry I didn't complete that, the opposite of b over 2a is equal to the x value. Now x is just the generic variable that's most commonly used. In this particular function though, we don't have an x value, we have a t value, so the vertex formula here is opposite of b over 2a is equal to t rather than x. So I'm going to say t equals the opposite of b, which is negative 64, divided by 2 times a, which is 2 times negative 16. So this is negative 64 divided by negative 32, which is 2. Now, t in this case, and I apologize, I should have been more specific. When it says at time t up here, that's in seconds. So this t value right here, the value of t is in seconds. So this is saying 2 seconds. And that answers one part of the question, is how long does it take to achieve the maximum height? We don't know what that maximum height is yet, but we know how long it took to achieve it. It's 2 seconds. Now, if we were to graph this, rather than labeling the axes with an x and a y, because of the way the function has been generated, the x-axis is really t for time, and the y-axis is h of t, or height. The y value is the height, the x value is the time. So to find the height now, I just need to plug that time value back into the function. So I need to find the height at time 2. So 2 squared is 4, 4 times negative 16 is negative 64. 64 plus 2, or times 2 is 128. Negative 64 plus 128 is 64. And this height is in feet. So we know now the maximum height happened to be 64 feet, and that occurred at 2 seconds. So this answers part of the question. The maximum height was 64 feet. This answers the other part of it. It took 2 seconds to achieve that height. So just going back and reviewing, really the important thing of this lesson is finding a vertex. You find the vertex either by completing the square, if it's in general form, to write it into standard form, or you can use the vertex formula to find the vertex. Once you know what the vertex, the location of it, you decide whether the vertex is a minimum or a maximum value. If the parabola opens up, that means the vertex is at the bottom, so it's a minimum value. If the parabola opens downward, then the vertex is at the top, making it a maximum value. And then another key thing to remember from this lesson is when you're solving an application problem dealing with quadratics and it says find the maximum or minimum, that means you're just really finding the vertex. So hopefully that helps. Don't wait to get started on the homework. Get started right away so you can have enough time to practice it.